Remote connections have been around for a long time, even before the internet existed. The biggest drawback to remote connections was the cost to connect. If you were on one side of the continent and had to connect to your LAN on the other side of the continent, the only connection option was a telephone. Or if you needed to connect two LANs across the continent, you ended up paying outrageous monthly charges for a private connection. The introduction of the internet gave people wishing to connect to their home networks a very inexpensive connection option. But there was one problem. The internet was and is open to the public. People wanted to stop using dial-up and expensive private connections and use the internet instead. But they wanted to be able to do it securely. Several standards use encrypted tunnels between a computer or a remote network and a private network through the internet, resulting in what is called a virtual private network, or VPN. An encrypted tunnel requires endpoints, the ends of the tunnel where the data is encrypted and decrypted. In these tunnels, the client for the application sits on one end and the server sits on the other. Either some software running on a computer or, in some cases, a dedicated box must act as an endpoint for the VPN. The key with the VPN is that all of the computers should be on the same network, and that means they must all have the same network ID. For example, you would want the laptop that you are using in an airport lounge to have the same network ID as all of the computers in your LAN back at the office. But there's no simple way to do this. If it's a single client trying to access a network, that client is going to take on the IP address from its local DHCP server. In this case, of the laptop in your airport, the network ID and IP address come from the DHCP server in the airport, not the DHCP server back at the office. To make the VPN work, you need a VPN client program protocol that uses one of the many tunneling protocols available, like PPTP or L2TP. This remote client connects to your office LAN via its internet connection, querying for an IP address from its local DHCP server. In this way, the VPN client will be on the same network ID as the local LAN. The remote computer now has two IP addresses. First, it has its internet connection's IP address, obtained from the remote computer's ISP. Second, the VPN client creates a tunnel endpoint that acts like a network interface card. This virtual network interface card has an IP address that connects it to your office.